Hey everyone, hope you're doing great. In my last video, we learned that Snowflake stores data in micropartitions, uses columnar storage, and relies heavily on metadata to avoid scanning unnecessary data. But none of that matters if there is no engine to process your SQL. That's where the compute layer comes in. So today, I'm going to show you what actually runs your queries in Snowflake, the compute layer. By the end of this video, you will understand what virtual warehouses really are, how Snowflake achieves massive parallelism, how scaling works, how Snowflake saves cost automatically, and how to optimize both performance and cost. If you are a data engineer working with Snowflake, this is essential knowledge. Let's start with the foundation of the compute layer. Snowflake's compute layer is made of virtual warehouses. And the most important thing to remember is warehouses do not store data. They only process data. They are stateless, which means the compute does not remember anything after the query finishes. In the last video, we saw queries being served from cache, but that doesn't mean the compute layer is stateful. Snowflake warehouses are stateless by design. The state lives in the cloud services and storage layers, not in the compute layer. And they can be started or stopped anytime. Think of compute as a temporary muscle. When you run a query, Snowflake spins up compute, processes the data, returns the result, and then the compute can shut down. This is very different from traditional databases where storage and compute are tightly coupled and always running. If we look at a virtual warehouse, it's not a single server. It's not even a single virtual machine. It's actually a cluster of compute nodes working together. When you create a warehouse in Snowflake automatically provisions a cluster of machines behind the scenes. You don't see them, you don't manage them, you don't patch them, you just use them. This is why Snowflake calls them virtual. So the key advantages of a warehouse is it's independent, it's isolated, scalable, and stateless. This means two teams can run heavy queries on the same data at the same time using different warehouses without slowing each other down. This is a huge architectural advantage. Additionally, Snowflake uses massive parallel processing. That means when you submit a query, Snowflake does not run it on a single machine. Instead, it breaks your query into multiple smaller tasks and distributes them across multiple nodes. Each node processes a chunk of data in parallel. Then Snowflake merges the results and sends them back to you. Here is the analogy. Instead of one person lifting 100 kg, Snowflake uses 100 people lifting 1 kg each. That's why Snowflake scales so well. Scaling is very important. Snowflake gives you two types of scaling: vertical scaling and horizontal scaling. Vertical scaling is resizing your warehouse. You can scale from extra small to extra large size. When you resize, you get more CPU, more memory, and achieve more parallelism. This helps individual queries run faster. And horizontal scaling is to achieve concurrency. If 100 users hit your database at the same time, Snowflake can spin up multiple clusters for the same warehouse. Each cluster handles a subset of users. So, vertical scaling is for faster queries and horizontal scaling is for more users. Additionally, we also see auto-suspend and auto-resume features available in Snowflake. This is where Snowflake saves you money. When a warehouse is idle, Snowflake automatically suspends it. No compute, so no billing. The moment a new query comes in, it resumes automatically. This is why Snowflake is so cost efficient for spiky workloads. Snowflake also does workload isolation. You can create one warehouse for ETL, one for BI dashboards, one for data science, and one for ad hoc queries. All of them can hit the same data. No locking, no contention, no fights for CPU. This is impossible in most traditional systems. Now, before we jump into the demo, it's important to know that Snowflake's compute layer has evolved. Starting in 2026, Snowflake rolled out some major improvements to its compute layer. Snowflake now supports Generation 2 standard warehouses, often called Gen2. Gen2 is the next evolution of Snowflake's standard virtual warehouses. They are designed to deliver better performance for analytics and data engineering workloads. It's built on faster underlying hardware and includes smarter execution optimizations, especially for heavy operations like table scans, deletes, updates, and merges. In many cases, this can result in up to 2.1x faster performance, and more importantly, it allows you to do more work concurrently on the same warehouse size. To use Gen2, you can specify it directly in the SQL using either generation equal to 2 clause, which is the recommended approach, or the resource constraint equal to standard Gen2 option. This applies to warehouse sizes from small up to 4XL, but not to 5XL or 6XL. Gen2 warehouses are available across AWS, Azure, and GCP in most regions with a few regional exceptions. Also keep in mind that these settings must be configured using SQL since Snowsite currently does not support them. And finally, for many new Snowflake organizations created after mid-2025, Gen2 is now the default, meaning you may already be using it without even realizing it. Now, while Gen2 focuses on making standard analytics and data engineering workloads faster and more efficient, Snowflake also introduced something called Snowpark-Optimized warehouses for a very different class of problems. They are designed specifically for memory-heavy workloads, things like Python-based processing, machine learning model training, complex UDFs, and large in-memory transformations. Instead of just scaling CPU, Snowpark-optimized warehouses let you scale memory aggressively, offering configurations up to 16x or even more memory per node. You control this using resource constraints like memory 1x, memory 16x, and memory 64x, and you can convert any existing warehouse into Snowpark-optimized one using a simple SQL. That said, there are a few important trade-offs. These warehouses can have slightly slower cold starts, and some of the higher memory configurations aren't available in all regions yet. So the idea here isn't that Snowpark optimized warehouses replace standard ones, but that they give you a specialized tool when your workloads are memory bound rather than CPU bound. One important clarification: none of these enhancements change the core design principles. Snowflake still gives you stateless compute, massive parallel processing execution, vertical and horizontal scaling, auto-suspend and resume, and workload isolation. What Gen2 and Snowpark optimized warehouses do is extend your options for handling different workloads more efficiently. Now let's get into the demo. Okay, let's open the warehouses. This is where Snowflake Compute lives. Each of these is a virtual warehouse, a separate compute cluster. Notice they are independent. They can have different sizes, and they can be running or suspended. This is how Snowflake achieves workload isolation. So let's go back and create a warehouse. With this query, I'm creating a warehouse called demo_warehouse. It's extra small, the smallest size that's available. I have enabled auto suspend after 60 seconds and auto resume. This means Snowflake will automatically shut this down when it's idle and automatically start it when a query comes in. This is why Snowflake is so cost efficient. Let's go back to the UI and refresh it. Now we can see demo_warehouse is started. Remember, the warehouses are stateless. That means this warehouse does not store data, it does not remember queries, and it does not hold any persistent state. It just processes requests and disappears. Let's run this query to get the data. The moment I run this query, Snowflake automatically spins up compute. I didn't start the warehouse manually, I didn't provision anything, Snowflake did it for me. This is auto resume in action. Let's refresh the warehouse. It's already in started status. Let's go back and wait for the results. Okay, now we can see the results. It executed in 46 seconds. Now we'll stop running any queries and wait for 60 seconds. Then Snowflake automatically suspends the warehouse, which is in started status. Okay, so after 60 seconds, the status of this warehouse is suspended. That means no compute running, no billing, no waste. This is why Snowflake works so well for spiky workloads. So now I'm going to vertically scale this warehouse from extra small to large. I can run this query and it scales from extra small to large. So this does not change the data, this does not change the schema, this does not change the storage. It only gives you more CPU, more memory, and more parallelism. This helps individual queries run faster. So let me disable the cached result and let me rerun this query again. Now this is going to run on a larger warehouse since we have changed the size from extra small to large on this warehouse. So it ran in approximately 8 seconds. So notice the difference in execution time. This is vertical scaling in action. Bigger warehouse means faster single query performance. This query is being split into smaller tasks, distributed across multiple nodes, processed in parallel, and then merged back together. This is why Snowflake scales so well. Now I am enabling multi-cluster mode by running this query. This is horizontal scaling. Notice that this does not make a single query faster. Instead, it allows Snowflake to spin up additional clusters so more queries can run at the same time. This is exactly what you want for BI dashboards, reporting tools, and high concurrency workloads. Now I'm going to create another warehouse by running this query. Now I have two warehouses, one for analytics and one for ETL. If I refresh the UI, I can see two different warehouses are available. Both can hit the same data without blocking each other. So no locking, no contention, no fights for CPU. Now I'm creating a Gen2 warehouse by running this query. The key part here is this parameter, generation equals to 2. That's what tells Snowflake to use the next generation compute engine. So what we saw in this video is that Snowflake's compute layer is stateless. It automatically scales for concurrency, it auto-suspends when idle, it's fully isolated, and it runs using massive parallel execution. And now with the Gen2 and Snowpark-Optimized warehouses, Snowflake gives you even more flexibility to match the right compute to the right workload. So that's all for this video. Thank you for watching.